Hi guys, this is the recording for laboratory 11, which is going to be analysis of wine. The goals for this laboratory are going to be to determine the titrable acidity in grams per liter of tartaric acid using the titration, determine the volume per volume percentage of ethanol using spectrophotometry, and determine pH using the pH proof. This part actually you won't do it, you will only use the information available uh, for your interpretation. However, starting from that pH information, you will determine how many grams of potassium metabisulfite. Potassium metabisulfite is just this compound over here uh, that are needed to regulate the wine pH and to prevent the spoilage of the wine. So this is a very important compound because this allows the pH of the wine to be maintained at a certain range, and therefore the wine lasts more, basically. Okay, moving forward, tartaric acid is the responsible for the taste of wine. Actually, this is the most abundant acid in wine and occurs naturally in grapes and wines. So that's the reason why. One important chemical consideration for tartaric acid is that tartaric acid is a diprotic acid, as you can see here. Diprotic acid means that this acid over here not only have one hydrogen ions, but two, which are responsible for the acidity of this compound when it's in solution. Therefore, this is going to be called a diprotic acid. One example for a monoprotic acid could be the one you guys used last time, hydrochloric acid, because if you notice, hydrochloric acid only has one hydrogen ion um, responsible for the acidity of it. Okay. Another important consideration is that we normally call hydrogen ions protons. It is the same. Okay. It's just for you guys to don't get confused if you look for information in the internet over the internet and you find the term protons. Protons is the same as hydrogen ions, just so you know. This is the reaction, this is the dissociation of the tartaric acid, where you guys have 1 mole of tartaric acid, which is going to be dissociated in two protons or two hydrogen ions, as I just told you, plus the counter-ion. And the whole equation for the titration you will be performing, you will be reacting 1 mole of tartaric acid with 2 moles of sodium hydroxide, which is going to be your base, to have in the end these products. Regarding the products, I'm not going to be really going over those are not really relevant, but what you guys need to know is that the relationship in this case between the tartaric acid and your base, or your acid and your base, it's gonna be a 1 to 2 ratio reaction relationship. So that is very important, and you need to know that information for you to have success during your calculations. So this is gonna be a 1 to 2 ratio, and you need to know that. Okay, moving forward, for the second goal of this laboratory, ethanol is a product of yeast fermentation in grape juice. Okay, so once you perform fermentation in the grape juice, you have a sugar, and once you ferment or that sugar, what you get in the end is ethanol, which is an alcohol, plus 2 moles of carbon dioxide. So normally, in order for you to get alcohol, you need to perform a fermentation. That's one of the, you know, all these steps to produce alcohol, starting from sugar. White wines usually have 12 to 14 volume per volume percentages of this ethanol, and normally this compound, ammonium cerium nitrate, is a compound that is used to detect ethanol, or well, alcohols in general. And in this case, what you guys can see is that this has the same role as phenolphthalein for the titrations. So once you add this compound, you can notice a change in color. And that's basically the reason why you can detect alcohol with this ammonium cerium nitrate reagent. Another important fact in this case is that a pH value is the measurement of the acidity. So I'm pretty sure you have seen this before, but this is the pH scale. Remember that in the pH scale, the lower the pH, the higher the acidity, whereas the higher the pH, the more alkaline or basic solution you will get. So, for instance, if you have a battery acid, that battery acid is going to be in a very low pH, which means it is very acidic. Whereas, for instance, if you are using bleach, that bleach is going to be really alkaline because it has a low concentration of hydronium ions. Normally, this is the formula to calculate pH. So it's always going to be equal to the negative logarithm of the concentration of the hydronium ion. The higher the concentration of this hydronium ion, the lower the pH it's going to be. As I told you, potassium metabisulfite, which is this formula over here, is used to perform, to calculate or to have a certain amount of free SO2 in wine to regulate the pH of that solution or of that beverage. Uh, so in this case, you guys will be referred to use the information in table number 1, which is going to be page 28, to calculate how much per volume of wine, how much of potassium metabisulfite you need to add to maintain a specific pH value. Moving forward, this is a brief resume of the experiment. So you will be performing three titrations. You will be using as your indicator phenolphthalein, so it's gonna be the same. So you should be looking for a change in color. However, here this is gonna be a little bit different because you will start with pale yellow color of white wine, the same color as always. And once you perform the titration and you reach your titration point, you should be looking for a salmon color, a really, light salmon color. So this photo explains quite well what I'm trying to say. You will fill the table in the lab report with information about the scout titrations plus the two careful titrations you perform, and then you will perform the sample solutions. These sample solutions has to be wine plus the ammonium cerium nitrate reagent I just told you about to determine the ethanol concentration, and you will be measuring the absorbances of these solutions at 563 nanometers. It has to be done immediately because otherwise, once you add this reagent over here, your solution will get wasted if you wait too long. So that's the reason why you need to perform this immediately. Then you will calibrate the pH probe. Of course, in this case, you won't do this, only you will get those pH values for your interpretation, but I'm trying to explain you what you should do. Then measuring the pH of the wine. And once you have this information of the pH of the wine, you can calculate the concentration of the tartaric acid, and you can calculate the concentration volume per volume of the ethanol in wine, depending on the absorbances you got for the calibration curve you construct. Then you can also find, starting from the pH value, the amount of the concentration of free SO2 in that wine for that specific pH. Once again, you need to go to table number 1. I will show that in a moment. And finally, once you have that concentration of free SO2, you can relate that and to the amount of potassium metabisulfite. So you can calculate the mass of potassium metabisulfite that you should need to add to the wine. Let me move forward. This is a brief example on how to make the calculation for the potassium metabisulfite mass starting from a specific pH. In this case, they are asking you about how many grams of potassium metabisulfite has to be added into 50 gallons of wine with a specific pH. So you always need to have a specific pH to start working with, because then you can refer to the table, and no prior free SO2. So this is an important statement. It can be a concentration of SO2, otherwise you won't be able to perform the calculation in this way, okay? So keep that in mind. We know the following information. This information is given to you, so work with it. This is very important. You need to consider that information, and then is just making the conversion. So first conversion always is going to be to change from gallons to liters, because the information in the table, and actually let me show you the table. This is the table you should be working with. If you notice here, blue color stands for the pH, and the maroon color stands for the free SO2 in milligrams per liter. So if you have a specific pH value, you can get how many milligrams per liter of SO2 you should have in that wine at that pH. Coming back here, so that table tells me that I should have 112 milligrams of free SO2 per 1 liter of wine. So once I change from gallons to liters, it's just relating those liters to get the amount of milligrams I should have for this volume. Once I make that change, I need to pass from milligrams to grams because all this information, as you can notice, is getting expressed in grams. So there's no point in working in milligrams. And once I pass from milligrams to grams, the final step is going to be just to relate that I should have 0.57 grams of SO2 per each gram of potassium metabisulfite. And in the end, you will get a mass of potassium metabisulfite. So I guess this is it for the video. Regarding exam number 3, remember that it's going to be available via Blackboard. You will have this available for 2 days or 48 hours, starting from April 15th. So keep that in mind, please. You have those 2 hours, but you cannot just, how can I explain this? Okay, so let me rephrase this. Once you start your exam time, you cannot just pause it. You have 2 hours from the moment you start. So please, once you start, keep working until you finish it and do not go to do any other thing in the meanwhile. Okay? It's very important that you know that. 2 hours is more than enough to finish the exam. The exam is not that hard. And in another video, you will see practice exercises I just made for you. Okay? Let me see. And I guess that's it.